to do question 8. 8.1 says that from first principles, determine the derivative if f of x is equals to 4x squared minus x. So we're going to use first principles to find the derivative of this problem here. So you have f of x being equals to 4x squared minus x, right? Meaning f of x plus h would be 4 into x plus h squared minus x plus h, right? If you write it, it's going to be x plus h minus x plus h, and we'll have x squared plus x multiplied by this is going to be xh, and this one here plus xh plus h squared minus into x plus h, and we'll have 4 into x squared plus 2xh plus h squared minus, so close bracket, minus into x plus h, right? So let's leave it here for now, our f of x plus h. So now let's find the derivative. So we have the derivative equals to the limit when h approaches 0, f of x plus h minus f of x divided by h. So the limit when h approaches 0, so what is f of x plus h is this expression here. So it's 4 into x squared plus 2xh plus h squared, close bracket, minus into x plus h, right, divided by h. Then we're just going to multiply the 4 inside here. So we're going to have so we have the limits when h approaches 0. So what is f of x plus h? It's this expression here, which is 4 into x squared plus 2xh plus h squared, close bracket, minus x plus h, right? So this is f of x plus h minus, what is our f of x? Our f of x is this one here, so it's going to be 4x squared minus x, right? And then we divide by h, so it's divide by h, right? So the limit when h approaches 0, so we're just going to multiply the 4 inside here. So it's going to be 4x squared plus 8xh plus 4h squared minus x minus h, right? This minus will multiply everything that is inside. So it's going to be minus, this minus will also multiply everything that is inside here. So it's going to be minus 4x squared plus x divided by h, right? So we're just going to have, so we're going to have limit when h approaches 0, so it's going to be 4x squared plus 8xh plus 4h squared minus x minus h excuse me, minus 4x squared plus x, so it's plus x there, divided by h. So now we're going to cancel out this minus 4x squared with this plus 4x squared, and the x goes away with this x, and then we remain with these expressions here. So it's going to be the limit when h approaches 0, so it's going to be 8xh plus 4h squared minus h over h, right? So we can factorize h. We can factor out h. So it's going to be h into 8x plus 4h minus 1 divided by h. So this h will divide out to this h. So you have limits when h approaches 0. So we have 8x plus 4h minus 1. So where there's h, we're going to substitute 0. So it's going to be 8x plus 4 into 0 minus 1. And we'll have 8x plus 0 minus 1, which is equals to 8x minus 1. So this is our derivative of f of x using first principles. So now we're going to do 8.2, where we are asked to determine in 8.2.1 the derivative of this expression here. So we have d of x into x squared minus 1 over 2x cubed plus the root of x, right? So the first thing before we derive, we need to change this root of x, right? So it's going to be d of x into x squared, and we're going to take this up because we want to derive it. So it's going to be minus x to the power of minus 3 over 2, and then plus x to the power of 1 over 2, right? So now we can derive this expression. We will have 2x, the derivative of this, and minus into, we'll drop the minus 3, so it's going to be minus 3 multiplied by x over 2 to the power of minus 3 minus 1, and plus, so let me close bracket here, so it's plus 1 over 2 into x to the power of 1 over 2 minus 1, right? So we have 2x plus, because the negative multiplies the negative, 3x to the power of minus 4 over 2 plus x to the power of, so 1 over 2 minus 1 will give you minus 1 over 2 divided by 2, right? And then we'll have 2x plus, so we can't leave it like this because can't leave it like this since the exponents are negative. So we need to make sure that the exponents are positive. So we need to drop this expression down. So it's going to be 3 over 2 x to the power of 4 plus, so there's 1 here, so it will remain, and then we drop this expression down. So it's going to be 2x to the power of 1 over 2 like this, right? So now you can leave it like this if you want. This can be your final answer, or you can simply write it as 2x plus 3 over 2x to the power of 4 plus, so let me write this, so it's going to be plus 1 over 2 root of x. So this can be your final solution, or you can write this one as your final solution. Do 8.2.2. We're going to find the derivative of this expression here. So we're having y is equals to k minus 2p to the power 2. So to find the derivative, to find the derivative, we have to expand this first, right? Because the derivative must be d of y over d of k. So you're just going to say k minus 2p, k minus 2p, and find the product. So k multiplied by k is k squared, k multiplied by 2p it's minus 2pk, and minus 2p here also multiplied by k, so it's minus 2pk, and then plus this minus 2p multiplied by minus 2p is plus 4p squared. So to write this nicely, k squared minus 4p of k plus 4p squared. So this is y is equals to k squared minus 4pk plus 4p squared. So we're going to derive the expression of y with respect to k, right? So we're going to derive this k squared, so it's going to be 2k. And if we derive this, it's going to be minus 4p, because we're deriving it with respect to k, right? We're deriving k with respect to y. So then this one here is going to be 0. So it's just going to be plus 0. So d of y over d of k is equals to 2k minus 4p. So this is the solution for this problem here. We're going to do 8.3, where we are given functions f of x and g of x, and we are told that they share the common tangent at point x being equals to 2. Calculate the value of p. So what we know is that the tangent passes through f of x, it also passes through g of x at x is equals to 2. So for us to find this value of p here, we first need to find this value of g of x, because already here we know x is equals to 2, right? So if we can find this g of x, then we'll be able to find the value of p. So for us to find g of x, which is actually y, we need to substitute in f of x. We have f of x being equals to minus x squared plus 9, right? We want to find the y value. So we know that x is equals to 2, right? Why am I substituting this in this f of x? Is because the tangent passes through f of x and g of x. So the y value of f of x is the same as the y value of g of x, right? Cool. So let's substitute this x is equals to 2 inside the f of x, right? We're going to substitute 2, so it's going to be 2 squared plus 9 is equals to minus 4 plus 9 being equals to 5, right? So our y value is equals to 5, and our x value is equals to 2. So now having these, we are going to find the value of p, right? Using the equation of g of x. So in g of x, it's g of x equals to p over x minus 3, right? And I said g of x is the same as having y. So it's y is equals to p over x minus 3. So where there's y, you'll put the 5. So it's going to be 5 equals to p over the x is 2 minus 3, right? So we have 5 equals to p over 2 minus 3, and then you transpose the minus 3 to the other side. We have 5 plus 3 equals to p over 2. We have 8 here is equals to p over 2. You cross multiply, p is equals to 16. So this is the solution of p.